All right, this time let's look at how to determine if a function demonstrates even or odd symmetry. We call functions even functions if its graph is symmetric about the y-axis. The one famous y equals x squared. If we graph a quadratic function y equals x squared, we're going to have 0, 0, 1, 1. Square of 2 is 1, 2, 3, 4. 1, 2, 3, 4 over here. So we're going to have a graph going up in the first quadrant like that. We also, if we plug in some negative numbers, negative 1 squared is 1. Negative 2 squared is 1, 2, 3, 4. Because of squaring, the negative goes away, right? So we have a graph that looks like this. This graph right here is symmetric about this y-axis. What's special about, because now I'm trying to explain this part for you. Look at the order pairs over here. This order pair is 1, 1, and this one is 2, 4, right? The ones on the left, this one is negative 1, 1, and this is negative 2, 4, okay? To be symmetric about the y-axis, if you plug in a positive 1, the y value should be the same as what you get by plugging in negative 1. You notice how the y values for positive 1 and negative 1 are both 1, right? If you look at the other ones, the y value for positive 2 and the y value for negative 2 are both 4. So if you plug in an x value and get some kind of f of x, then if it's an even function, you can get that same f of x by plugging in negative x. Okay, so what we're going to say is if it's an even function, because it is symmetric about the y-axis, f of x equals f of negative x. That's what they are saying, okay? Basically, what we are saying is, I guess looking at this example makes it easy. Plugging in positive 1 and plugging in negative 1, you get the same y value. Plugging in negative 2 and plugging in positive 2, you get the same y value. So if you plug in negative x, you get the same y value. So if that happens, the graph will be symmetric about the y-axis, and we call those even functions, okay? Now, please be careful because some functions who has even degrees are not necessarily going to be even functions. For example, y equals x plus 3 squared, okay? Some people say, oh, the degree is 2, therefore it must be even function. That's not true. Because if you graph this one, if you graph this function, we have to shift 3 to the left, right? Because of this horizontal translation. And then if you're going to have a graph that looks like this. Now, this parabola is symmetric about this axis of symmetry at x equals negative 3. This graph is not symmetric about the y-axis. So, only the graph who are symmetric about the y-axis are called even functions, okay? Some even degree functions are not going to be even functions, okay? All right, how about the odd function? We say functions are odd if you graph it and the graph is symmetric about the origin, okay? So if you have something in the first quadrant, and it is symmetric about the origin, you're going to have this, like a same looking piece rotated in the third quadrant. And for me, that's kind of hard to see. That's why I kind of like to do these algebraically. But what we're going to do in this short video, I'm just going to kind of go over 6 pictures, 6 graphs. And by just looking at the symmetry, we will determine if these graphs are the graphs of even or odd functions. Okay, the first one, what do you think? We can see this graph is definitely symmetric about the y-axis because this piece of the graph and that piece of the graph are symmetric by this y-axis, right? So this first one is an even function, okay? Because the graph is symmetric about the y-axis. Let's see if there's any other even functions here. What do you think? Now, I should have probably labeled these. I call it A. I'll just label these right now. B, C, D, E, and F. Even functions are kind of easy to tell because we just like imagine folding this graph by the y-axis. If you fold it and if it's, like a butterfly, I learned how to make these butterfly. I don't know, I forgot what to call it. But if it's the same to the right and same to the left of the y-axis, then they are even functions. Anything else that you see? What else is even here? D, right? This is also an even function because the graph goes down and comes up to the right side, and it does the same thing, down and comes up. So this is definitely an even function. And I think that's it for the even function. C, I trick a lot of people with C. C is, though, it is not symmetric about the y-axis. It is symmetric about this line x equals 2. But it's not really, to be symmetric about the y-axis, what I should have is a graph that looks like another half circle like that. But we don't have that, right? So this is not an even function, and it's not even going to be odd either. All right, let's take a look at some other graphs. Like, for example, B right here. This is an example of an odd function because we have a graph that's going up to the right in the first quadrant. Imagine, if you can, try to imagine rotating this around 180 degrees, okay? Can you imagine? I wish I have a tool to do that. I don't think I have a tool in this note-taking app, but this piece of graph, if you rotate it, it's gonna like lie down like right on top of this. That's my best explanation, I'm sorry. But this is a graph of an odd function, okay? I'm sure I may be able to find some better videos of other people using some kind of applet to show this rotation and symmetry. But what I will do is probably on your first exam, I will not ask you to determine symmetry graphically. I will just keep it as doing it algebraically because I think that's a little more straightforward. But let's see if there's any other odd functions. How about C? If this is an odd symmetry, symmetric about the origin, I should have a graph that's looking like this in the third quadrant, okay? But we don't. So guess what? C is, I'm going to say, C is neither. It's not even or odd. It's not symmetric about the y-axis. It's not symmetric about the origin, therefore it's neither. All right, what about D? We already called it even. How about E? E is pretty good. It's not even though, because to be even, if this is part of the graph to the right, I should have a graph something like that. We don't have that, so this is not even. How about odd? Let's check out odd. To be an odd function, I should have a graph, and this is going to be difficult for me. If I rotate this around, I should have a graph that goes like this in the third quadrant. And the thing is, this could have been an odd function, but it shifted up a little too far. They shifted up 3 units. And I think it's also shifted a little bit to the right too. But this one's a tricky one to tell. But this one, it could have been an odd function, but because it's not symmetric, what's seeing in the first quadrant? You see, the first quadrant, you have this piece and this piece. If this is an odd symmetry, I should see something similar to this, like 2 pieces in the third quadrant. What I see is just a random single piece. So that kind of shows that this is not an odd function. I don't think I'm doing such a good job explaining even odd symmetry graphically. So I will probably end up finding videos to supplement these part. But all right, let's do the last one. How about this one? I can see in the first quadrant, I have this piece coming up, and I can imagine rotating this 180 degrees or find the symmetry about the origin, and I can see how this piece will come down, rotate down to this piece, and this piece right there will rotate down to, this one's hard to see, to this piece right there. What about the other one that I did not mark? Well, this one up there is in the second quadrant. So if I rotate this around, the big time, it's going to show up in the fourth quadrant just like that. So I think this is an odd function because this is symmetric about the origin. I can imagine if I can use a Photoshop or something to show you that. But if it's just on a piece of paper, we have to use our imagination to find that symmetry or see that symmetry. But that's how you determine graphically whether a function is even or odd. And that's just by looking for the symmetry either by the y-axis or the origin. I am definitely going to find some other cool videos where other people use apps, like they have these cool things now. So I may find and add that to our canvas, but I want you to, if this part was confusing, I want you to definitely take a look at the next video where we go over examples to determine the symmetry algebraically. That will be, I tend to put, I'm sorry. I tend to put those type of problems on the first exam instead of the graphing kind. And I also know you will see some good examples and videos on Alex or by checking out the textbook section too, okay?